Hey everyone, so today we are going to see an example of an inner product on the polynomial space. Okay, after that, once we see that it's an inner product, we are going to see an example where given two polynomials, how can you find the angle between those two polynomials, and also how to find length of the polynomial using inner product. After that, we will going to ask few questions regarding the inner product that I am going to define. Also we will see the answers, and after that we will see that is there special anything about this number, that is there something like that you can only define this many number of inner products, or this number is irrelevant. So all these questions I'm going to answer. Well, I took this number because this is also one of the very nice number. Why is a mysterious number? For this I have recorded one lecture. The link you will find in the description, so make sure you have a look. Okay, so let's go one by one. Let's first try to define at least one inner product on the polynomial space. So let me take my vector space as P2x, set of all polynomials of degree less equal to. We know that this is a three-dimensional vector space with usual addition and scalar multiplication operation. Now let me define an inner product from V cross V to R, because I'm treating this as the vector space over real numbers. An inner product of P comma Q, I'm defining it as you evaluate P and Q at -1, take the product. You evaluate P and Q at 0, you find the product. You find P and Q at 1 and you find the product, and then you sum it up. So this is what the function I'm defining. Since each of them is a real number, so their addition is a real number. So this function is from V cross V to R. Okay, now let's go one by one. Will it satisfy the four properties of inner product? Okay, even before that you can ask me, is this -1, 0 and 1 anything special? Can I take some other numbers? Can I have 1, 2, 3, 4, 5 terms? Can I have only one term? If I don't take what will happen? So I'm going to answer all this question, but let's first play with the nice things. Okay, so what is the first thing? The first thing is positivity. So I need to prove that inner product of P comma P. Now when I'm writing P means P of x. Okay, so inner product of P of x comma P of x is greater or equal to 0. That's what I want to show. But what is inner product of Px comma Px? It is P of -1 into P of -1, means P of -1 square. Then what is P of 0 into P of 0? It is P of 0 square, plus P of 1 into P of 1 means P of 1 square. Now as you can see, this is a number, real number, and I'm taking its square. This is a number, I'm taking its square. This is a number, I'm taking its square, and I'm adding it up. So obviously this is always non-negative. Okay, so therefore P comma P is always greater or equal to 0. So therefore this property holds, non-negativity. Okay, what about the second thing? The second thing, if you remember, inner product is 0 if and only if your polynomial is a 0 polynomial. Now is this obvious? Yes, even this obvious. So let's go one by one. Suppose your P is 0. Okay, suppose your polynomial is a 0 polynomial. Okay, then what will be inner product of P comma P? What will be P of -1? Since polynomial is 0, your P of x is what? It's a 0 polynomial. So you replace your x by 1, -1, 0. Does not matter, there is no x. Your answer is always 0 over here. So this is nothing but 0 square P of -1 square plus P of 0 square plus P of 1 square, which is 0. So if the polynomial is 0, then the inner product is also 0. Now let's try to prove the other way. Now suppose our inner product is 0. We want to show the polynomial is itself 0. So here you need to do some work. What is inner product of P comma P? P of -1 into P of -1, P of 0 into P of 0, P of 1 into P of 1. So all of them are non-negative, and I'm saying their sum is 0. That means what? Each of the terms should be 0. But all of them are real numbers. So if the square is 0, the term is itself 0. Okay, in real number, if a square is 0, then your a is itself 0. Right? Okay, now what is P of -1? Now how your any P of x will look like? Your P of x will be nothing but a2x square plus a1x plus a0. This is how your any polynomial in V will look like. Okay, now what is P of -1? If you do, it is a2 minus a1 plus a0 equal to 0. What is P of 0? It is only a0. you replace your x by 0. So a2 into 0 plus a1 into 0 plus a0. What is p of 1? You replace your x by 1. So a2 plus a1 plus a0 equal to 0. Now this will give you your a0 to be 0. So your a0 is 0. So let me remove a0 from here. Now you add this equation and this equation. When I add them, minus a1 plus a1 is 0. I get a2 plus a2. So I get 2a2 equal to 0. If 2a2 is 0 means what? Your a2 is 0. As soon as your a2 is 0, you put a2 equal to here. That means what? Your a1 is also 0. So this three condition implies that your a1, a2 and a0 all are 0. That means what? Your polynomial is 0. So therefore if the inner product is 0, then what did we prove? We proved that your polynomial is a 0 polynomial. So therefore both the properties are satisfied. Now let's go for the linearity. So here inner product of p of x plus h of x comma q of x, where p, h and q they are in our vector space V, polynomial of degree less equal to. Now by the definition, what is the inner product? It is p of minus 1 plus h of minus 1. The first polynomial you evaluate at minus 1 multiply by the second polynomial evaluate at minus 1 plus first polynomial evaluated 0 into second polynomial evaluating at 0 plus first polynomial evaluating at 1 into second polynomial evaluating at 1. Now you simply take this inside, the first two terms, take this inside, remaining two terms, multiply q of 1 inside the remaining terms. Now if you observe, PQ is over here, PQ is over here and PQ is over here. So if I take these three terms, if you observe, that is nothing but inner product of P comma Q. Now if I add the remaining three terms, this term, this term, this term, HQ, 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 which is nothing but inner product of H comma Q. So therefore the inner product that we have defined, that satisfies the linearity property as well. Now let's go for the symmetry property. Now inner product of PQ is, this is the definition. Now see, P of minus 1 and Q of minus 1 both are real number. So if you have two real number, then you do x into y or you do y into x. You both times get the same answer. So this thing is same as Q of minus 1 into P of minus 1 by commutativity of real numbers. Similarly, I have interchanged this, I have interchanged this. But what is this? This is nothing but inner product of Q comma P, because first we are writing Q polynomial. Okay, so this is nothing but QP, QP, QP. So this is nothing but your inner product of Q comma P. So therefore the inner product that we have defined, that also satisfies the symmetric property. Now what about the scalar multiplication property? Lambda PQ. So this is nothing but lambda P at minus 1 into Q at minus 1 plus lambda P at 0 into Q at 0 plus lambda P at 1 into Q of 1. Now what is this? But lambda P of minus 1 is what? Lambda into P of minus 1 into Q of minus 1. Because lambda is just a number, so you can take out number outside. Plus lambda into P of 0 into Q of 0 plus lambda into P of 1 into Q of 1. Now you can take out lambda outside from each term. And what is this? Lambda into inner product of PQ. So the inner product, so the function that we have defined, it satisfies all the 5 properties of inner product. And therefore the given function is an inner product on the polynomial space of degree at most 2. Good. So we now have the inner product. Now as soon as you have the inner product, the good thing you can do is you can find the angle between the polynomials. And you can also find the length of the polynomials. So let's see an example on these 2 points. Now suppose P of x is this polynomial, is of degree 2, Q of x is also of degree 2. Now let's first find the inner product of P and Q. What is that? P of minus 1. What is P of minus 1? Minus 1 square minus 1 plus 1 into what is Q of minus 1? Minus 1 square is 1, so 2 plus 4. What is P of 0? 0, 0, 1. What is Q of 0? When you put 0, you get only 4. What is P of 1? 1 plus 1 plus 1. What is Q of 1? 2 plus 4, 6. Simply put x by minus 1, 0 and 1 respectively. Now what is this? This is only 1, so this is 6 plus 4 plus 18. So if my calculations are correct, inner product of PQ is 28. Okay, now what is inner product of P comma P? It is nothing but P naught, P of minus 1 square plus P naught square plus P of 1 square. What is P of minus 1? We just found it was 1 only. So this is 1 square. What is P naught? That is also 1. So 1 square. What is P1? It is, so this is what we have. So 9, 10, 11. So this is 11. And what is the inner product of Q comma Q? It is Q naught square, which is nothing but 4 plus 6, 6 square plus 4 square plus 6 square. So 72 plus 16, 86. 72 plus 16, 88. Yeah, just correct me if my calculation is incorrect. 36, 36, 72, 72 and 16, yeah, 88. So seems to be correct. Fine. Now once we have these three things, how do you find the angle between the polynomials or angle between the vectors in arbitrary vector space? So cos theta is inner product of P comma Q upon the length of P into length of Q. Right? Now what is inner product of P comma Q? It came out to be 28. Right? So now I don't need this part. Now what is length of P? Length of P or the norm of P of X is nothing but square root of inner product of P comma P. So this is divided by square root of 11 into square root of inner product of norm of Q is 88. Right? And now I think you can do the calculation. This is 28. This is 11 8s. So this is 11 into root 8. This is again 2 root 2. You do the calculation and the first thing is you should tell me what is the angle between these two polynomials. So whenever someone asks you find the length of the polynomial, the first thing you should know is what is the inner product. As soon as you have the inner product, using this formula you can find the length of the polynomial. Once you have the length of two polynomials, for example, then you can find the angle as well. Okay, so once you have the inner product, you can always find the length and the angles. Okay, so the first thing is you have to pause the video and you have to tell me what is the angle, what is the theta between these two polynomials. Okay, cool. So now we have an example. Now one can ask me that I have taken P of minus 1 into Q of minus 1, P of 0 into Q of 0 plus P of 1 into Q of 1. What if I take only one of the condition? What if I take not three condition? Then it will not form an inner product. So let me give an example. Suppose if I define a function from V cross V to R as P of X comma Q of X is P of 0 into Q of 0. If I take only one term, will this form an inner product? Answer is no. So if I, for example, if I give you P of X equal to say X square plus X, right? This is a non-zero polynomial. But what is inner product of P comma P? It is P of 0 into P of 0. What is P of 0? 0 into 0, which is 0. P of 0 is nothing but 0. So your P is not a zero polynomial, but your inner product is coming out to be 0. So earlier we proved the second property. Polynomial is 0 if and only if the inner product of P comma P is 0. That property gets failed over here. So only giving one condition will not help you. Suppose if I give you two conditions, P of 1 into Q of 1. Will this help me? Answer is no. So your job is give me a polynomial where this property fails. Your inner product will be 0. Your inner product will be 0, but your polynomial is non-zero. So give me a non-zero polynomial whose inner product is 0. Okay. So even if I put two conditions, this will not help me. So this is the second homework. First homework is to tell me the angle. Second is pause the video and think of a polynomial whose inner product is 0 if I am taking this as the function. So therefore even this will not form as an inner product because this property will fail. Okay. Now one can ask me, so now I took three conditions, right? Plus P of minus 1 into Q of minus 1. If I take one more, say P of 2 into Q of 2. Is this fine if I take more than 3? Answer is yes, that does not matter. Okay, you can take 3, 4, you can take 3, 4, 5, 6, not an issue. The only thing is your computations will increase, that's the only thing. So when you write the program, it will decrease the efficiency. So when you can do by 3, then why to go for 4, 5, 6 terms? Okay, so since, and why only 3 is working here, minimum 3 is required because P2x is a polynomial of dimension 3. So since it's a dimension 3, you will need something plus something plus something if I'm defining of such kind of inner product. Okay, so less than 3 will definitely not help me. Greater or equal 3 will always help me. It will always give me the inner product. Okay, so that is one thing to observe. Okay, now second thing one can say, what if I take inner product P comma Q as say P of 0 into Q of 1 plus P of say 7, not, let me take small number, P of minus 1 into Q of 0 plus P of 2 into Q of 1. Then what? Will this work as an inner product? Answer is no. So you have to give me an example. Again, I think the positivity will fail. So I have not given a thought on this, but I would be happy if someone comments on this part, whether this forms an inner product or not. Actually, you can see, I think you will get a negative answer for this. That's what the first two property, inner product PP greater or equal 0, either that will fail or yeah, I think that will fail actually. So think over this. If many of you will not get, I will keep on checking the comment section. If many of you will not get, then I will give you an example for this as well, that why if I take different numbers, then it will not form an inner product. Okay, so these were some small questions that one can ask after looking at the example which I stated. This plus this plus this. Will less than 3 will work? No. Greater or equal 3? Yes. If I take different numbers? No. So now another question people can ask, why only minus 1, 0 and 1? What if I take 1, 2, 3, like P of 1 into Q of 1 plus P of 2 into Q of 2 plus P of 3 into Q of 3? No harm, you will still get an inner product. And that's where we will answer the question. Can you give me 6174 inner products on P2, for example P2x? Answer is yes. And actually you can give me infinitely many inner products on this P2 of x. So this is a very nice theorem, I will say, that if you take two polynomials, so I am playing with P2 of x. Okay, so you take P of t naught into Q of t naught plus P of t1 into Q of t1, I am taking the same numbers, okay, plus P of t2 into Q of t2, where what is your t naught, t1, t2, they are some fixed real numbers. Then this will always form an inner product on P2 of x. So I took minus 1, 0, 1. You take 1, 2, 3, get good, you will get an inner product. So you have two inner products. You take 5, 7, 10, great, you will get one more inner product. You take minus 13, minus 14, pi, great, you will get another inner product. You take 1.2, 1.7, 3.9, great, you will get another inner product. So you keep on changing this distinct, okay, so these are distinct. You get different inner products. So there is nothing special about 6174. But in this case, you can keep on changing this and you can give me infinitely many inner products on P2 of x. Okay, so if someone says, okay, can you give me 1 lakh inner products? Yes. You give him 1 lakh different combinations. You have 1 lakh different inner products. But 6174 is a good number. Okay, I have stated this because I want you to look that lecture on 6174. What is the mystery behind 6174? Okay, so link you will find in the description. Okay, now one can ask, this was about P2, what about P3 or P1 or P4 or P5? Don't worry, the same theorem gets generalized. So if you take suppose P4 of x, polynomials of degree at most 4, what is the dimension? Dimension is 5, right? So you define inner product of, you take any two polynomials of degree at most 4 in this vector space, then you define this as, you take any 5 numbers you want because the dimension is 5, right? So you take P of 1 into Q of 1 plus P of 0 into Q of 0. I always take simple numbers so that they are easy for the calculation. And say P of 3 into Q of 3. You choose 5 distinct real numbers, evaluate your P and Q at those numbers, and then you take the product. Then this will give you the inner product. And this works in general as well. So P of t naught into Q of t naught P of T1 into Q of T1, P of T2 into Q of T2, P of T3, Q of T3, P of T4, Q of T4, where T0, T1, T2, T3 and T4, they are distinct real numbers. You take a pair of 5 distinct real numbers, you plug in over here, you get an inner product. You take another 5 distinct pair of real numbers, you plug in here, you get another inner product. So if you have Pn of x, and if you take any two polynomials of degree at most n, you take summation P of Ti into Q of Ti, where I is running from say 1 to n, where your T1, T2 up to Tn, they are distinct real numbers. Then for so it's n, so it is n plus 1 dimension, right? So I should take n plus 1, so T n plus 1. So see the dimension and take that many summation of the products, then that will always give you an inner product on that polynomial space. If you want to go till n, you go from I from 0 to n. Okay, so this will be n plus 1 terms. So like this you can give me infinitely many inner products. So now I hope you are comfortable with the inner products on the polynomial space. You are comfortable in finding the angles between the polynomials. So you should know inner product for that. Okay, so I hope you understood this lecture. Do not forget to answer those 2 questions. You have to tell me the angle and you have to give me a polynomial which does not satisfy that P of 0 into Q of 0 plus P of 1 into Q of 1. So that is not forming an inner product. So I hope you understood this lecture. If you have any doubt regarding this, you can, or other than this, you can ask me in the comment section. And if you understood this lecture, then do not forget to like, share and subscribe. Thank you.